Well, good morning. Let's get started. My name is Steve Gordon. I'm currently the chair of the SIGHPC Education Chapter of ACM. And this morning we have a presentation on extending computational training through informal means. And our speakers today are Dhruv Chakravorty and Rick McMullen. So Dhruv, I'm going to turn it over to you. Please introduce yourselves and get started on your presentation.
Hi, I'm Dhruv Chakravorty. I'm the User Services Manager at Texas A&M High Performance Research Computing.
And I'm Rick McMullen. I'm the Associate Director. And I just wanted to mention that Dhruv is the first author on most of the work in this presentation. So he's the one you want to address your questions. And,
nice work.
just to be clear.
All right, so let's get this started. Okay, so share, go here, and we click slideshow. Is this good? Okay, and then let's move this.
Yeah, that's good.
Okay, Rick, all yours.
Oh, okay. So, so what we want to talk about today is three different projects we've been working on recently to evaluate different approaches to teaching programming and computational or technical computing skills for a broad range of people and applications. So the first part of this, first I want to, whoops, hang on. Yeah, so I just wanted to mention that we have a cast of characters here who've been involved in doing these activities and putting together the papers about them. So we'd like to acknowledge them. This list is hopefully exhaustive, but if we forgot anybody, our apologies. The outline for this talk, we're going to talk about these three different approaches. First two are training kinds of things. This is as opposed to academic formal courses and things like that. The third section is going to be talking about NSF cyber training for a cybersecurity project. So I'm going to just do the first part here about our overall view here. So I think we might all agree that there's some lack of support for learners, not only at the intermediate level, but probably all levels of computing. And what we need to do is to consider a couple of different key areas. One is the audience, what their needs and current skills are, and we need to address those needs in sort of visible, usable, and learner-friendly approaches. And a part of the activities here were around using or evaluating different pedagogical methods for addressing these different audiences and needs. Another really important thing that we think is really critical is to try to collect numbers about what you're doing so that you can make data-driven decisions about what you're doing and how to change it and make it better. So overall, these are three things, three projects that could potentially be adopted elsewhere. So the first section here I want to talk about is our own in-house training classes for our users. And typically this starts off, you have an HPC center and you have a bunch of users and you want them to be effective with the equipment as quickly as possible. So that's the bedrock of what we're doing. But it also extends into a broader community of users who may not be your high-end users, who are also interested in scientific and technical computing. And you can use these methods to address that broader audience as well. And this is work that was presented at PERC this summer. All right, so we have this in-house training program. There are three key parts to this. One is the sort of curricular issues. What do we You know, how do we handle the materials? The technology, what are the delivery platforms? And then the third one is how do we make it stick, or at least make the attendees feel like they're walking away with something. So one point here I want to make is that this whole program was initially designed around you know, how to use the cluster, and it's really gone beyond that. It would started off as in-person computer lab training, and we're now doing it using WebEx. So our audience base has expanded tremendously. And off to the right, you can see how the participation has grown. It appears, the way we're looking at it is we're hoping that we have an annual cycle with two fall and spring semester cycles. So one thing we're trying to figure out is what's the right way to lay our classes out over that time period so that we get incoming graduate students and maybe undergrads who are at the senior level who want to do projects and make sure that they are trained up and effective in a reasonable amount of time. So we offer a whole lot of classes. This is a pie chart. So if we take all the registrations that we have in a year, and then we divide out the attendance or the registrations for each of these sub classes, this is what we come up with. And this was kind of a way to answer the question, well, what are people interested in? And so I guess the three that pop out immediately for core skills are things like Linux, Python, Skippy, and R come out as basic tool skill things people are interested in. In terms of approaches and technologies, we have also significant interest in machine learning, things like TensorFlow, and using platforms like MATLAB and NVIDIA CUDA training as a way to learn about those approaches. Oops. Okay. Let's see. Sorry, I'm losing control of this button. Okay, so what to offer and who's interested? This chart on the right is a distribution of departments and participants. So the biggest slice of the pie is engineering. That's more than half of our registrants. Another big section is the ag division and also the College of Sciences. There's a big section there, XX, labeled other academic institutions or other entities, and these are things that we either identified as being outside the university or perhaps were not properly assigned to a category. So since Texas A&M is primarily an engineering school, that's not surprising, but we are interested in supporting both the School of Science and the Ag school since we are a land grant kind of institution. The kind of questions that we need to answer to do a good job are things like, what do we want to offer? Where is the best place to do that? Do we want to have a central site, or do we want to go out into the departments and meet people where they live? Scheduling, what's good? People are generally available for short things, but not for long sessions. So we have to look at days and the schedule. And then some other questions about how long, what kind of instructional model do we want to use, and so on and so forth. So these are the questions we're using to refine this set of attendance records that we have. In terms of evaluating what we're doing, we have a sort of standard survey model where we ask basic things. How did you learn about the course? Why did you register? is this something that you're just interested in, or is it central to your research or degree plans? And then kind of feedback on the course itself. What are the strengths and weaknesses? And then where do you want to go from here? How do you plan to use this? So those are open-ended, and then we had some liker questions. So part of this is the research methodology. How do we want to elicit the most useful information as quickly as possible from our users? Okay, so if we have 30-some different classes that we offer, what does it mean to people? And so one of the key issues that we're looking into right now is what is persistence? What do people, are people interested in following specific tracks, developing their skills in a particular area, or are they just showing up once to see what it was like? And so this is an interesting graph. I guess the biggest issue here is that, or the biggest observation is that at least half the people go on to take another class, which is good. So that indicates that somehow we are, we're creating an environment where people want to take more classes. The other thing that we've observed is a lot of people will just show up for special purpose classes like TensorFlow or something, and they come from where they are, and they go take the class and then go off and use those specific tool skills. And so there's no notion of a track or incremental building up of knowledge. So this is kind of an important technique that we're using to figure out how to organize classes. I mean, are people more interested in highly topical things that are in the news, or do they want to be in it for the long run to learn a set of skills in an organized manner? Okay, so I'm going to stop there and then turn this over to Drew and let him talk about another aspect, another teaching program that I have.
Hi, morning, everybody. So, Rick gave a pretty exhaustive description of what we're doing for our students, and a lot of the students taking our courses, the informal courses that we offer on Fridays, are graduate students. But over the last year or so, we found that undergraduate students are showing up, especially for courses such as Python, MATLAB. And, we asked ourselves the question, what do we need to do to support these students? And one of the things, we came across early was there is a lot of data out there on how to teach someone something new in computing, but how do you support someone who's at the intermediate level, who knows a little bit of, say, a programming language such as Python, and then wants to extend further and wants to get to the next level up? How does one go about doing it? So we did the study over a summer, and I'll talk about that. So experiment was basically we wanted to define undergraduate, at the undergraduate level, what is an intermediate programming concept? And we had a robust discussion on this for weeks at end about, if the introductory level is, say, Python, and you've taught loops, is the intermediate level a new programming language, or is it more complex topics within Python itself? Well, based on the slide, you can guess that Python won out, and we decided to go with more complex topics in Python, both in terms of the programming aspects and in terms of the type of projects that one could accomplish by using Python. Our focus has always been on hands-on learning. We found that to be an incredibly effective tool for learners. So, we've favored active learning practices. And the challenges for us then become, what kind of projects can students work on which are closer in nature at the intermediate level? So we figured that the Raspberry Pi microcontrollers gives us a sense to include more hands-on and project-based learning topics. So that was means of choice. We included activities that focused on sensor-based games, cryptography, and artificial intelligence. There's a lot of interest in these, so those made good topics to engage people. And we explored three different avenues to teach Python. The first was more based on hands-on projects which connected code to sensing and controlling real-world scenarios. The second was incremental learning through Jupyter notebooks that used guided exercises. So now students don't have to write the code, but they can work in Jupyter notebook cells. And then the third aspect we essentially presented the students with the problem, and we taught them the tools, and then the students were expected to solve the problem by using the tools they already had at their disposal. So we wanted to see how it worked out. For our methodology, we had a set of 23 intermediate level learners, 7 students were female, 13 belonged to traditionally underrepresented groups in computing. All our applicants completed a pre-training evaluation that gauged their familiarity with Python, programming, Linux, and Raspberry Pi computers. The selection to this program was merit-based. All participants had basic Python programming skills, a GPA of 3.5 or more, and were likely to attend college. And because it's the early undergraduate level, our focus was on students who were going to show up in college either that year or the next year. Students were required to have a prior experience with the Linux operating system and text editors. So it was a niche group, but for the first year of the study, I thought we did well in attracting the people we wanted to. Our students belonged to 2 learning groups. Group 1 were 12 self-identified intermediate level Python learners. These were folks who said, I'm already there. I'm good at this, and I can take on these challenges. And group 2 were 11 learners who had participated in our Python programming course, which was held 2 months before this exercise. So going in, we had a feeling that group 1 would be disadvantaged and group 2 may have a slight advantage. And I guess that's why we do these studies, to find out who really is better. This is one of our questionnaire questions on the application, which was ask questions like, how familiar are you with the Raspberry Pi? And you go from no experience to being a Pi chef and other similar questions. We also have essay-style questions where students are asked to describe their motivation to learn programming and their level of expertise, and we also require letters of recommendation for this program. So once again, this was not a broad-based program, it was merit-based, and we did select the best students, but it gave us some insights. So step 1 is making sure that everybody in group 1 and group 2 was up to speed, was at the same level. And we definitely wanted to build confidence in these students, get some people who are highly talented, but they may be shy or they may not be used to the environment. So we divided the 5-day program into 1 day of just getting to know each other, revising all the material everybody should already know. So we used a set of exercises that brought them up to speed on Linux, on using a text editor such as gedit, and we reviewed basic programming constructs in Python. A sample exercise is on the right. All activities had learning objectives, there were detailed instructions, and we included advanced activities in our exercises so that, say student X finishes the activity, and instead of him or her twiddling their thumbs, can go ahead and do the next thing on the project. All right, so our first set of activities were pretty text heavy. I apologize for how busy this slide is, but it kind of conveys what we were trying to do. So in the first exercise, you'll find that it revolves around connecting sensors to the Raspberry Pi. And there's a rich assortment of sensors available, both touch sensors, sound sensors, you can attach buzzers. So, it's a lot of fun, students love it. And within this, we wanted to cover programming concepts such as classes, comparison operators, include user input, and loop constructs. So in this course, we had brief lectures, and then students were allowed to program, and each time they reached a topic which would be new, as you can see on the slide, that's where the instructor would lecture, and then the students were again allowed to explore the programming modules on their own. The hands-on activities included connecting sensors, controlling buzzers, and flashing an LED light. We had a capstone where students created the Simon Says game using LED sensors, and a color stacking game using a Pi hat. The second set of exercises were on machine learning and artificial intelligence. That was really entertaining because people have preconceived ideas of what machine learning and artificial intelligence is. So a part of the day was in fact spent on introducing students to what is meant by accuracy, what is meant by training, how do accuracy and training affect your final product. So it was not just programming, but they learned something more on top of it. The hands-on activities were training using a recognized database. Students could recognize hand-drawn numbers. Students could accurately predict images that were available online, and they learned how to use CNNs for image recognition. The capstone exercise was creating a training platform to classify images, and Jupyter notebooks were used, as you can see on the right, and students were urged to manipulate data sets or their training data and images in the Jupyter notebook platform. The final set of exercises we did were based on real-world problem solving. In this scenario, students discussed a real-world problem. In this case, it was cryptography and the need to establish security in communications. We discussed why it was relevant to the world. We showed them in a more or less typical classroom manner the theoretical portions of the exercise. We didn't jump into the code, and students were given hints on what they could do. They already had the tools at their disposal. They knew the programming constructs they needed to use, and they were let go, and instructors were around. They walked around and students could ask them questions. The interesting thing about this approach was each activity had multiple possible solutions, unlike previous units, and that led to some interesting data. So the hands-on activities in this study were encrypted data. Students had to encrypt a data set, and they decrypted the data from the previous activity. In terms of Python, students were given examples of the Diffie-Hellman algorithm implemented in Python scripts, and the capstone was that each student was challenged to decrypt communications from other students in the class using their own code. All right. In addition to watching student performance on the capstones and the in-class activities, we performed surveys as well, and Rick went over some of these. In addition to the typical survey questions we also asked essay-style questions and interviews, which were more focused on what were the topics that were difficult to learn, that were easy to learn, what was enjoyable, and what was engaging. The results were interesting. This is the broad overall set of data that we collected. And so all participants completed the week-long program. This was important to us. We had no one drop out, which for us was very warming, and we were very excited about that. We had a day camp style program, and the number one thing that everybody wanted was a residential style camp. We had 3 instructors teach the topics, as in each instructor taught a separate topic. We found that students were okay with all of them, and neither male or female students had a preference for male or female instructors. So even if you're male, you're doing okay, even if you have a lot of female students. Python was a popular choice. 100% of students approved of it as a programming language for the intermediate level. Linux was less popular among students, and possibly they wish they didn't have to do as much of that. The course content was appropriate at an intermediate programming level. 90% of students agreed with that, and the exercises were engaging and appropriate. Participants felt that computing did not play quite an important role in everyday life, but was critical in research. We have some theories on this, quite possibly because computing is so pervasive in everyday life that one doesn't pause and stop to think about what, how it impacts us. What was a big surprise to us was that students with prior computing experience, that is group 1, the self-identified intermediate learners, were better prepared for the program compared to students without any experience, but were familiar with the camp structure. And this was really interesting for us because it essentially showed that perhaps people with a broader base of knowledge are more likely to learn newer topics as compared to those who are being directed to the new topics itself. This was a surprising learning for us. More specifically, on makerspaces with sensors and Raspberry Pi had devices, these exercises scored highly in terms of processing ideas and taking ownership of ideas. This was very popular among students. But students who had not developed these skills previously struggled in these exercises. So when it came to Jupyter notebooks, the good thing was everybody finished the exercises. Participants could successfully manipulate the notebooks, and they could all complete their training sets, their changes to the training sets, manipulate the number of epochs. But while all students could perform the exercises, the theory of machine learning remained unclear to a few of them. Understanding of concepts was demonstrated by students who broke the model by manipulating training data or could put in fake images, and 30% of our students were able to complete this, which essentially showed that a Jupyter notebook can helped drive a process to completion, but learning gains were debatable. Problem-solving exercises in cryptography, the interactive nature, and the ability to solve real-world solving problems was very exciting for students. 100% of them enjoyed it. The approach was more complex in scenarios when there are a large number of possible solutions. And students really struggled with this, the whole idea that they could use any tool at their disposal to reach an appropriate solution. All right, so we're going to stop on that section and talk a little bit about our virtual reality work, where we are developing modules to enforce principles of cybersecurity. This is an NSF-funded project, and we thank the NSF for funding in this. Rick?
Oh, okay. All right. So this project was started under the notion that we wanted to explore what different groups, in particular, our target audience, scientific computists, might need to know about cybersecurity and how to get it to them. So that was the original idea, which turned out to have an interesting corollary, and that is, if you engage visualization people on a project, your project will change. So we we had a good association with some folks who did created virtual environments and did training in those environments, and so we turned our interest to what we could do with that, and a kind of a basic set of skills is navigating physical security. So this is probably not something your typical computational scientist is going to run into on a day-to-day basis, but since it was something that we dealt with in the real world on a day-to-day basis, we thought this was a worthy project. So, so that was the motivation. So what we're trying to do here is to go take the set of skills requirements for being able to deal with the physical security part of working in a data center environment and turn that into some interactive training that people enjoy and find engaging. So this project was driven by some standards, course NIST 853, and some implementations of that regarding physical access. So we're focusing on the data center. We're using some parts of 853 in our training model, and assuming that no sane data center is going to want to let untrained people experiment and learn on the data center's time, so we want to do this as a virtual thing. So that was the background. We are, I guess, moving into some fairly broadly used technology for VR. We thought an immersive experience with a lot of feedback for an individual was probably the right way to go, as opposed to a more 2 or 2.5D game thing. So, and it also gives you at least, maybe not muscle memory, but some memories of how to navigate in that environment that can translate directly into physical access. So do you want to take it from here?
I can take it from here. All right, so we're adopting virtual reality as a tool to teach cybersecurity, and the driving factors where participants can explore consequences to their actions. So it's an environment in which that truly interacts with participants rather than them being forced through an exercise. And we've had students who've broken the game, and we'll talk about that a little bit. And the idea for us is we're trying to build it up to where participants can collaborate with simulated characters and learn complex tasks, so that, and perhaps even work with each other in a virtual environment that would really make online, which is probably the next challenge in online training. For us, the most important aspect of building a virtual reality environment was that students at a community college today cannot enter a data center without jumping through a lot of hoops. Even at Texas A&M, a student on campus, for him or her to enter a data center and see what's really happening in the physical aspects of it, it remains a challenge. We needed an environment that was safe as well. So this gave us an opportunity to explore how virtual reality could be used to this advantage. So the SIGHPC virtual reality program is a system that utilizes virtual reality, reinforces further knowledge of cyber skills through exercises. And we offered this via one of our camps, and to see how students were engaged, how they could participate. And after the camp, our plan is to now introduce this program in a class this semester, and students can continue their learning experience through in-person and online short courses and seminars. User training scenario has 3 situations, that is entering the data center, inspecting current nodes or any kind of equipment you have over there, and the final stage is replacing the machinery. So I have some screenshots for you. This is a screenshot for where you enter the data center. On the screen, you will find that there are some red lines and some blue discs. These are guides for people in the simulation where they can follow a path or a trajectory inside. You could literally spend the entire day sitting on one of the chairs. That's not recommended, but it is an option for our participants. To enter the data center, students have to swipe a key card, and there's a biometric scanner, and these are the 2 images on the right. Let's see if this video works. So this is once you've entered the data center. And as you can see, you can point your pointer to the ground and navigate to any part of the data center.
Use it to open the rack.
We have audio as well as visual cues.
Pull out the Ethernet cables.
And in this situation,
pull the node out of the rack and place it on the card.
The student replaces
Remove the
a
node from the
defective
rack
node.
and place it on the card. Move the card to the workshop area.
Okay, let's see. All right, so after the video, in the next stage, a student can take the node to a virtual workshop. They can open up the node. They can see different components of what's in a node and replace a memory card with a new memory card and put the node back in where it belongs. The entire simulation takes between 6 minutes to 25 minutes, depending on how familiar someone is with virtual reality. That is a challenge we're still working on. So in terms of evaluating this process, we had 25 students who were part of our Summer Computing Academy program run through this exercise. We had pre and post exercise questions, and the post exercise questions were posted a week later. And in terms of information recall, students remembered the data center's physical security aspects, the procedure of fixing a node with broken memory in the VR application. 90% of students remembered this after the session, and 80% remembered it after 1 week. So if you really want to teach people on how to do something and you have 80% retention, I feel pretty good about it. Some of the feedback was that VR is very interactive, so it would be a good way to teach students and will keep them engaged. It is easy and fun to use, and it is easy to remember information. When it came to us using this program, I think the most interesting thing was watching students try to break the program. I guess it's something we have to get used to. That really helped us refine the program, and we were able to demonstrate this at Supercomputing as well. All right, I'm going to give this to Rick. He can talk about the path forward.
All right, so these are 3 different projects focusing on different aspects of learning in our general environment. And so we're trying to figure out where to go next. I mean, we have some basic tasks with managing our training classes and things like that. But we would like to have community folks take a look at what we've done. Our materials are available on our website. You're welcome to use this material and let us know how things go. One thing that we have that we leveraged, and Drew did a great job of this, is to motivate student workers to teach classes. Properly vetted, of course. But what we found was, if one of our student workers had a skill set that was applicable to one of our audiences, we tried to encourage that person to either teach an existing class or put a new one together. And that's been very interesting for all of us. Certainly, I guess the bottom line is you learn things better if you have to teach it. We are also using parts of the material that we've developed for these informal short classes in educational courses, and we have gotten some response from faculty along the lines of, oh, well, we'd like to have these particular skills taught in our classroom so students can quickly go on and do other things. Example there is in computational chemistry class and physics class, if you need to know how to do certain activities in Linux or use compilers or whatever, then this is a quick way for them to get that material inserted into their own classes. We have found that it's really essential to measure things, and surveys are fine. We like surveys because we think we understand them, and it's certainly a good way to do longitudinal studies, assuming you have the discipline to try to think out your surveys correctly to begin with. Another thing for especially for developing, doing these bigger experiments involving workshops with students, we found it's very good to understand the details of what the participants know and don't know. So pre-event tests of various types and assessments really help us understand not only how to direct the activity ahead, but also to figure out what learning gains have been accomplished. This is a very interesting area for us to work in, and I really appreciate all the work that SIGHPC folks have done in the past and will continue to do in the future. And just like to point out that we consider this hard work and appreciate other people's efforts, and really want to express our interest in participating in the broader community. So let's see.
Okay, so I guess.
So you can do that.
All right. So in summary, I think one of the major learnings for us has been that computing offers opportunities to build collaborations with multiple units on campus. So these programs have helped us work with departments, with government agencies, and as well as institutions on campus. We gratefully acknowledge funding from the NSF. A whole slew of people have helped these programs, without whom this would not be possible, and this extends beyond the authors on the paper so far, and we're very grateful to it. As Rick said, I would once again highly encourage people on this call or watching this later to visit our training website, download our materials, send us feedback, cite our papers, and if you have any questions, send us an email at help@hprc.tamu.edu. We'll get back to you for sure. With that, I'll open the floor to questions. Thank you.
Thank you very much, folks. So right now, let's ask the audience for questions. You can either unmute and ask them verbally, or if you want to put them in the chat window, I'll pass that along to the presenters. So I have sort of a technical question waiting for others. In one area, you said you were using virtual machines to teach some of the Python courses, and I wondered if that is any challenges in terms of setting that up and getting people familiar with the environment to use that.
Yeah, so the basic problem was we wanted to have a training environment that we could stand up quickly and then trash. So that's why the VM. The actual environment is just a Linux, like CentOS or something like that, and the users have accounts that they log in on, and so it was pretty straightforward. We didn't have any technical issues. Now the biggest thing here is we cannot teach detailed HPC things that involve a cluster with a VM. So that's a little out of scope. But for everything else, VMs are really good.
Okay. Other questions from the audience? I haven't looked at your training materials directly, but to what degree are they tied to that virtual environment or your local environment? If somebody wanted to use them in in a different environment.
Well, some of them are tightly tied. I think all the VM ones are very general. There are classes like how do you actually do submit jobs, and whatnot. Those are very site specific,
Right?
Transferable. If you use LSF or Slurm, no worries. They're just details that need to be changed.
Yeah. Okay.
So, for example, if you're looking at Intro to R and you want to learn about R, it's highly transferable. But if it is something more specific like Introduction to our clusters, I think it'll be challenging to transfer that to other environments. Like the concepts are pretty much the same.
Yeah.
But cluster usage, that is more specific for our users.
Gotcha. The audience is very quiet today, so I'm not seeing any other questions come up. So let me ask just one other thing. Based on what you learn in the workshops for summer, where you have a more intense 1 week thing, you mentioned taking off pieces of those and getting them into classrooms. Could you say a bit more about what modules faculty are requesting and how that's going?
Okay, so the answer to that is that doesn't apply to the summer thing. That only applies to the short courses.
Okay.
The summer thing we're looking at as well. How do you, how would you transfer some of this into regular classroom education? But certainly subparts of the the more intensive short courses, that's quite relevant.
So if you think of it as a tiered training approach, so for example, the summer aspects inform our short courses, and then the short courses turn into classroom activities in more formal efforts. So for example, in year one, the way we taught Linux in our introductory camps in the summer really changed how we were teaching Linux in our short courses, and its modules from the short courses are what faculty typically ask for.
Okay, great.
Hi, this is Jayashri. I have a question.
Yes, Jayashri, hi.
Hi, I looked at your training website and it says training materials available for download, but if I go to your training website, I can't find it. All I could find was sign into lynda.com using your TAMU.
Hold on. Let's go. Yeah.
Am I missing something?
Everything that I'm working on.
Online training. There are some available online training materials.
Can you see what I'm doing?
Yeah, no.
No?
I'm still seeing your slides.
Oh, okay. So maybe I need to do something with this. Hold on. Larger.
I'm at your training website.
So are you on the HPRC training website?
Yeah. Mm-hmm. Then the short courses, workshops, and online training. There are also some available online training materials.
If you scroll down in the short course list for fall 2018.
Okay.
And over there, you'll find there's upcoming courses and previous courses.
Mm-hmm.
There are no more upcoming courses. Everything has moved over to previous courses. So if you click on that tab, you'll find our list of short courses.
Yes. Thank you.
A long time ago. And if you need all the short courses from even years past, we have that stored as well, and we can share that link. This is the most up-to-date version.
Okay.
It was getting bloated, so I think our webmaster decided to reduce how much was. And then there's a link which takes you to every course which was offered in previous semesters, and you can get that data as well. But Jayashri, thank you so much for trying it out.
Thank you. I'll explore the material. Thank you so much.
You're most welcome.
I can ask a question. You mentioned at some point that you were hoping to specifically work with community colleges to give some of those students access to high-performance computing. What is your plan there? Do you have relationships with folks? Do you have, because I know that's kind of an interesting group of folks to break into with HPC.
Yeah, so that has been an interesting environment to work with. So we were fortunate that some of the students in our summer computing academy, their parents work at community colleges. So we've been able to build on that relationship. We work fairly closely with the Texas A&M Cybersecurity Center. And at the Cybersecurity Center, some of the people have a long-standing relationship with Blinn Community College. And we are slowly building up a relationship with people who work with the Houston Community College. Part of the challenge in the Houston and Dallas Community College, and perhaps even San Antonio, I'm not that well informed about San Antonio, is that the community college systems are distributed. And so you might talk to one person and then the other, and you might be working with one person who does nothing with someone else in that same. So what we are hoping is some of the modules we're developing, we can then effort at the community college level. Rick, do you want to add to that?
No, but I would agree that yeah, it's hard to break in, and I think the real question is it's important for us to identify within a community college what they think the emerging important things are that they want to do, and you know, what new curricula they want to offer. So we approach them with, you know, here's a set of training materials, and you know, if you have something specific in mind, we will help you adopt these and alter them to fit your specific needs. But yeah, it's you know, at the junior college level, it's hard. People they're very goal directed, you know, and on the other hand, I guess there is a track of students who are college or university bound, for which they're getting basics out of the way, and maybe that's an interesting area if they have extra time to pick up new skills as well. But we haven't really been able to formulate a good plan for addressing that.
Yeah, we've had an interesting time interacting with faculty too. They seem to get really excited about the HPC stuff and about the Raspberry Pis and all of that, but then when it comes time to actually implementing it in their curricula or getting it to the students is where we kind of have a gap. It kind of falls off right there. So it's interesting that you guys are having a similar experience. What's that?
I was just going to say they're underpaid and overworked.
Yes, absolutely.
And really, you know, junior colleges are businesses. The same situation applies in high schools without that business push of trying to get students through and into jobs. So in some sense, we get the same level of enthusiasm in high school, but those folks have a little bit more time and willingness to put effort into adopting some of these things.
All right. Are there any other final questions today? For those who are with us or who are watching this later, I just want to put in a plug. You know, these webinars are sponsored by the SIGHPC Education Program chapter, and we welcome new members, which is it's just a modest fee of $10 a year for professionals and $5 for students, and that means that you get informed about all of these kinds of events, and can also participate in helping us engage the community in these training and education kinds of activities. So with that, let me thank the speakers again, Dhruv and Rick. Thank you so much for your presentation, and we look forward, just for those that are, for you, we'll have the video of this up probably in the next couple of days, and we'll send you a link so you can use that, refer that to others who might be interested.
Awesome. Thank you.
Yeah, thanks a lot, Steve. This has been a great opportunity, and we just put everything into the bucket, and I hope it wasn't too much or not enough detail or whatever, but we're interested in all these things and want to try to connect with anybody else who is.
Terrific. Well, thank you again, and everyone have a good day. Thank you for attending.
Thank you.
Bye-bye.